In this lesson, we will define the 6 trigonometric functions for an angle measure in a right triangle. This is going to build directly on the example prior to this section of the lesson, where we demonstrated that any triangle that holds the same shape as a 30, 60, 90, or 30 degree, 60 degree, 90 degree triangle, or a 45 degree, 45 degree, 90 degree triangle, can have defined side lengths that are ratios of the hypotenuse side. This is a concept of similar triangles, where triangles with the same angle measures are considered similar regardless of their size. The 6 trigonometric functions that we're going to see here will help us relate the acute angle measure in a right triangle to the side lengths of that triangle. We cannot simply relate one angle measure with one side length because the size of the triangle that has, say, a 30 degree measure may change. However, the ratio of two sides in the triangle with that 30 degree measure will stay consistent, no matter how large or small the triangle is scaled. So, each of the 6 trig functions here are simply functions that define particular ratios within that triangle. Each function will take an angle measure as its argument or independent variable, and will result in a dependent variable that is a particular ratio of sides. Or, in layman's terms, you put an angle measure in a trig function, either in degrees or in radians, and what you will get in return is a ratio of two particular sides. The side lengths in the triangle we will define relative to the angle measure in question. In this case, we're going to say theta is an acute angle measure residing in a right triangle. We will then define the adjacent side as the side next to theta, and we will define the opposite side as a side across from theta. Note that we are not saying that one side is called the opposite side in that triangle, and one side is the adjacent side in that triangle. It depends on the angle measure in question. If the angle measure was the one at the top of the one demonstrated in this box, then the side length that would be defined as the opposite is the horizontal side length here, and the one defined as the adjacent would be the vertical side length. It's all relative to the angle measure in question. The 6 trig functions that define the ratios of two sides are defined as follows. Sine is defined as the ratio of the opposite side over the hypotenuse side. Cosine is defined as the adjacent side over the hypotenuse side. And tangent would be defined as the ratio of the opposite side over the adjacent side. Those 3 trig functions are the primary 3 trig functions you're going to see in this course. The other 3 trig functions we have listed on the right are known as the reciprocal trig functions because they take the main 3 basic ones, sine, cosine, and tangent, and they take the reciprocal of them, or they flip the ratio. So, for example, cosecant would be the reciprocal of sine, so it is hypotenuse over opposite. Secant is the reciprocal of cosine, so that is hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so that is adjacent over opposite. Again, we are primarily going to work with sine, cosine, and tangent in this class. There is a mnemonic of sorts that some students use to try to remember these trig functions. That mnemonic is so, ka, toa. It's a word that rolls off the tongue relatively well. And what this word translates to is what trig function relates to what two side lengths. For example, the first syllable of this word, so, means that sine, the capital letter there, sine is the ratio of opposite over hypotenuse. The second syllable, ka, means cosine is the reciprocal of adjacent over hypotenuse. The third syllable, toa, I guess that's the last 2 syllables, means that tangent is the ratio of opposite over adjacent. That mnemonic may help, particularly earlier on when you're still getting used to these trig functions and what side lengths they relate to.